Hi, what's up, guys? This is Julius. I was kind of bored. The weather is kind of chilly. I can't go anywhere. So I just decided to make some video. This should be my first video. And if you may ask me, what kind of video are you gonna do? It's just simple. I am somebody who loves math. I love to mess up with numbers. But I'm gonna prefer doing video on calculus or in calculus, whatever. My English kind of sometimes mess up, but never mind. So I'm going to do videos in calculus. I think you might have heard of calculus. In my country where I come from, that is Ghana, we call it elective math. So I'm just trying to do some videos and share it with you guys. Right. So what kind of videos am I making? Yes, as I told you, it's going to be based on calculus. There's a basic calculus, and it's going to be on differentiations and integrations. Right. So let's get going. Let's say if I have a graph, say I have a straight line, then I have a curve. Now, this is my x-axis and this is my y-axis. All right. Assuming there is a line which passes, the line is not all that straight. Just bear with me. It's kind of crooked. Right. So that is the line which passes, it touches this curve. So let's say it touches it at a point here. Let's say A, B. Now, where it touches, I can call it a tangent. Where the line touches the curve, I can call it tangent. So let's say let's say this is my, from here, this is my y values. So let's say where it touches the point, then you trace it down. So the first line here, I can say y1, and then here I can say y2. Now down here, I can say, let's say x1, and then here x2. Now, how do I find the gradient? I have two values for x, that's x1, x2, and then y1, y2. So I'm trying to find the gradient. That is, in pre-calculus we call it gradient, but in pre-calculus, we call it gradient. But in calculus itself, we prefer to call it as a slope. So how do I find the slope or the gradient? So we just simply use the letter M to represent the gradient or the slope. It is the change in y over the change in x. The delta y over delta x. So if I want to find y using these points, let's say I have y1, y2, then I have x1, x2. So the change in y is simply y2 minus y1 over x2 minus x1. So that gives me the gradient, or I could call it the slope of that. So the slope, you can see the slope of the tangent or the gradient of the tangent, and that is what we call a derivatives. It is a change in y over the change in x. So that is what we call the derivatives. Right. So where am I driving this point to? Why am I doing all this? I'm doing it because we're going to tackle the differentiation. And differentiation is simply the slope of a tangent. Now, before we proceed, there is a formula which you have to apply to calculate or to solve any question concerning differentiation. Hold on. Now, if I have a function, let's say f of x, this is equals to y, let's say equals to let me say an x. To differentiate this, you have to use a formula. Let's say f prime of x. This is equals to f of x plus h minus f of x all over h. So this is what we're going to use to differentiate the function given. So let's see, how do we differentiate this? F of x is equal to y, which is equal to what? X. How do we differentiate it? Using this formula? So wherever you see x, this is the function, the value of x. X plus h gives us x. So whenever you see x, you replace it by that. And then f of x is the function, f of x equals to y, which is equals to what? X. Now let's apply that to solve for this. So have f prime of x is equals to, this is our x, so you replace it by x plus h. So you have x plus h, because just a single x. This is minus the functions f of x, and f of x is just x. So we have x, then divided by h. Right. And then here we introduce something called the limit. So we have f prime of x. We have the limit as h approaches 0. X plus h minus x and all over h. Right. Now we are solving for that. So let's, if you open brackets, so you have f of x this is equal to we have x plus h minus x and all over h. So f of x is equals to, this x goes with that, and then you have h all over h. So if you divide h by h, that gives me 1. So if you differentiate x, you come up with 1 as your answer. Right. Let's move on. Let's look at more examples. That's the first example. So let's go to the next example. Right. The next example I'm gonna tackle is this. So differentiate minus 60, y is equal to minus 16 a squared plus 96x. So remember, we're still going to use the same formula. Right. So let me remind you of the formula. F prime of x is equals to f of x plus h minus f of x all over h. So using the same thing to apply to this. So our f prime of x is equals to, so remember, wherever you see x plus h, so wherever you see x, you replace it by x plus h. So here you have x, sorry, this is negative 16x squared, so negative 16 into bracket because it's a constant, so you bring it outside. Then you replace this one by x plus h. Then remember this is a squared term. You cannot just write only x plus h. You have to square it, then minus f of x. Let's put it in brackets. So f of x is the whole of this function. So you have minus 16x squared plus 90. Oh, sorry. I haven't finished. Oh, sorry for that. Let's have a mistake here. Let's mess this shit up. Now, so you have f prime of x is equal to, you have minus 16. Then you replace your x by x plus h. Remember it is a squared term, so you square it. And then this is plus 96. There's an x here, so you replace x by x plus h. Right? And minus the function. You put the function f of x. This is the whole function. So this is into brackets minus 16x squared plus 96x. Right, we're having some fun. Now, this is just a simple algebra. Let's see how we can expand this. Oh, sorry, this is all over h. Almost forgot. So don't ever forget the h, but that is very important. Right. So, 16, negative 16. Let's try to expand this. If you expand x plus h squared, what are we going to get? So you're going to get x squared, which will give us plus 2xh